Our task today is to find the derivative of these two parametric equations. So in order for us to find the derivative of parametric equations, firstly, we individually differentiate the two equations. Then after individually differentiating the two equations, we then join the results using what is called the chain rule. So let us demonstrate what we mean. We do have y is equal to 2 cos 3 theta, and we have x is equal to sine 3 theta. When we are differentiating trigonometric functions, we use what is termed the PTA strategy. And what the PTA strategy stands for is, firstly, we differentiate with respect to the power. Then we go on to differentiate with respect to the trig or the trigonometric function. Then lastly, we differentiate now with respect to the algebraic function or algebraic expression. So remember this step. We are going to individually differentiate these equations separately, starting with y is equal to 2 cos 3 theta. Then we differentiate also x is equal to sine theta. Then the results we get from these differentiations, we are going to join them using the chain rule. So let us operate on this. Y is equal to 2 cos 3 theta. And we have in mind our PTA strategy. So let us differentiate this trigonometric equation or trigonometric function, firstly with respect to the power. So since we have a power of 1 here, even though it is not indicated, but we have the power of 1 here. So if we want to differentiate this, firstly, dy dx, but in this case, it's actually dy d theta, because the variables and the unknowns we have y and we have theta. So dy d theta is equal to this one multiplies this 2. So it's now 2 cos, then it's 1 minus 1, 3 theta. So we have differentiated with respect to the power, multiplying the derivative now with respect to the trig. And we know that the derivative of cos theta is minus sine theta. So the derivative with respect to trig will now be minus sine 3 theta. Then we multiply with the derivative with respect to the algebraic expression, which is 3 theta. So here it will be 3. Now, here we have 2 cos 1 minus 1, it's 0, 3 theta, multiplying minus sine 3 theta times 3. Any number or expression which is raised to the power 0 gives us 1. So instead of cos 3 theta to the power 0, we now have 1 here. And still multiplying by negative sine 3 theta, multiplying by 3. 2 times 1, it's 1. And this 2 multiplies this 3 to give us 6. So eventually we have minus 6 sine 3 theta. This is dy d theta, knowing that x is equal to sine 3 theta. So dx d theta will be equal to, we are supposed to follow the PTA strategy. Start by differentiating with respect to the power, then differentiate with respect to the trig, then lastly differentiate with respect to the algebraic expression. But because this trig does not have a power or has a power of 1, and since it does not have a scalar multiplying the trig, it's no need to differentiate with respect to the power because we are going to retain 1. Then it is a trig, but it also does has an algebraic expression. So we are going to skip the part of differentiating with respect to power. We are going to start off with differentiating with respect to trig. What is the derivative of sine theta? The derivative of sine theta, it's cos theta. So the derivative of 3 theta will be, so the derivative of sine 3 theta will be cos 3 theta. So cos 3 theta multiplying, now with respect to the algebraic expression, since it's just 3 theta, we know that the derivative is 3. To mean that our derivative of x will be equal to 3 cos 3 theta. Now, after having worked through this, we are now going to employ what we term the chain rule. And what does the chain rule imply? The chain rule implies that dy dx is equal to dy d theta dividing dx d theta. And before we go anywhere, let us examine this chain rule to see its implications. If we solve these two derivatives, or if we divide dy d theta divided by dx d theta, we know we are going to end up with dy d theta multiplying d theta dx. Because of the inverting property of dividing two fractions, dx d theta, when we are multiplying now, becomes d theta over dx. And we can cancel out this d theta with this d theta. Eventually, we will have dy dx. But the reason why we wrote it as dy d theta divided by dx d theta, the reason was we already have dy d theta and we have dx d theta. So we just need to directly substitute in the chain rule. Dy d theta, it's minus 6 sine 3 theta. This is dividing by dx d theta, it's 3 cos 3 theta. This is equal to minus 6 sine 3 theta multiplying 1 over 3 cos 3 theta, which is equal to, this 3 cancels out this. We now have minus 2 sine theta, sine 3 theta, multiplying 1 over cos 3 theta. And if we multiply numerator by numerator, we have minus 2 sine 3 theta times 1, which is minus 2 sine 3 theta over cos 3 theta. And from our knowledge of trigonometry, we know that tan theta is actually equal to sine theta over cos theta. Now this property, this knowledge, tells us that our final answer is minus 2 tan 3 theta. So this is how we calculate through parametric equations. This is how we derive parametric equations. This is how we operate parametric differentiation.